Okay, so in this video, I'm going to explain how to solve a second kind of inequalities problem, which is shown up in the GMAT. And so this question is essentially a quadratic inequality in disguise. This polynomial here can be factored into a cubic and a quadratic. And so the process of solving a quadratic inequality is fairly standard. You have to set the function equal to 0 and then find the zeros. And so we have x cubed minus 4x to the 5 as our function. So x cubed minus 4x to the 5. And we want to see where this is less than 0. But the idea is that if you think about a graph of a function, it's usually going to be less than 0 or greater than 0 in any given region. So, for example, if the graph looked like so, then we can say, if you look at this, that in this region here, it's above 0 completely. In this other region, it's below 0. In the final region, it's above 0. So the graph, given any region, if you find it zeros, the regions demarcated by the zeros will usually be regions where the graph is either above 0, greater than 0, or less than 0. So in this case, we want to find which regions, where the regions where the graph or the function's values will be less than 0. So we have to find the zeros first. So we set x cubed minus 4x to the 5 equal to 0. And then here, x cubed is a common term, so we can factor that out. Minus 4x squared. So actually, let me rewrite that. X cubed, when we factor that out, we have 1 minus 4x squared equals 0. So we can set x cubed to 0 and 1 minus 4x squared equals 0. So when x cubed is set to 0, we get x equals 0 as one of the solutions, or one of the roots of the function. And then we also set 1 minus 4x squared equals 0, which essentially, we can rearrange things. We get 4x squared equal 1, or x squared equal 1/4, which gives us x equal plus or minus 1/2 if you take the square roots on both sides. So we have x equals 0, x equals plus or minus 1/2. Like maybe if this were the graph, then these would be the zeros. So we want to find whether the graph is positive or negative in each of the regions. And so here, the graph was that was just a rough sketch. That's for the actual graph. But we're now going to find where the graph is actually below 0 or above 0. So our zeros are minus 1/2, or roots of the function, minus 1/2, 0, and plus 1/2. So we pick a value in each region. Here, in this first region, I can pick minus 1. That's to the left of minus 1/2. And our function is x cubed minus 4x to the 5. And we want to see where this is less than 0. So if I pick minus 1, then I get minus 1 cubed. That's my first test value. Minus 4 times minus 1 to the 5. And this is just minus 1 minus 4 times minus 1. This is plus 4 minus 1, 3. So actually, to the left of minus 1/2, the sign is positive. It's greater than 0. 3 is greater than 0. So now we need to test the next region, a value in the next region between minus 1/2 and 0. So I can pick minus 1/4. And if I cube that, minus 4 times minus 1/4 to the 5, what we find is, see, this is raising a negative number to the fifth power will result in a negative number, multiplied by another negative will give us a plus sign. Okay, so this is just going to be plus 1 over 4 to the 4. But if we look at this other term, it's minus 1 over 4 cubed. Because this power, the denominator's power is 3, this number would have a bigger magnitude than the one whose denominator is raised to the power 4. So we don't need the actual value, we just need to know that we have a negative value that's bigger than the positive value, so the overall will be negative. And then the next region is between 0 and 1/2. We can pick 1/4. And if we raise that to the power 3 minus 4 times 1/4 to the power 5. Again, this time we have a positive value, power is 3, and this will be a net negative, but the magnitude will be smaller. 1 over 4 to the 4 is the final value. It's going to be smaller than 1 over 4 cubed. So if we subtract, we're going to get a net positive value. You can verify that, but there's no need to go through the full calculation. We are only interested in the signs. And then finally, the last region to the right of 1/2, I can pick 1. If I do 1 cubed minus 4 times 1 to the 5. This is again 1 minus 4, which is minus 3 as my final answer. So here it's negative. So the signs are plus, minus, plus, minus. The regions where the function is less than 0, where we have the negatives, these two regions. So the answer to our question on our inequality, where is this less than 0? We have two regions. One is the region between minus 1/2 and 0, so x is greater than minus 1/2 and less than 0. And then the other region is to the right of 1/2, so x is greater than 1/2. So there are two regions that satisfy the inequality. And if we look at our answer choices, between minus 1/2 and 0, x is greater than minus 1/2 less than 0, that's this here. X is greater than 1/2, that's that here. So those are our two regions that satisfy the inequality. So the correct answer is C here. And so I hope that process makes sense. First, you have to find the zeros of a function, and then use that to specify regions. Each of the zeros will either have a region to its left or to its right, and we have to test numbers in those regions to see where the function is negative in this case. And we found two regions where the function has negative values, which is where this function will be less than 0. So I hope that kind of makes sense, and I'll be posting more videos on various topics, so stay tuned, and if you like the video, click like, and see you next time.